Okay, we're going to work on solving this single variable equation, okay? And they've given us a relatively tricky one here, probably purposely. They really want us to work on our fractions here. There's quite a few ways we can tackle this. We can try to get everything to be a like denominator or work in fractions. I'm going to go out on a limb and say you probably want to get rid of fractions. Most students, for better or for worse, don't like working with fractions, probably because they can get a little tricky. So what we can do as a trick, if we have a single term fraction on both sides of the equation, there's a really fast trick to get rid of a fraction. Now, on the left-hand side, so LHS, this side here, I have that. I have, kind of looks like a polynomial on top, but I have kind of like a single term divided by 5. This works out really nice because I can, if I have that on something similar on the other side, I can get rid of it really quickly. Here we don't have that. We have split two terms. So we are going to have to do a little bit of manipulating the right side before we can employ this trick. We need, because of the operation, this is a plus sign, we need a common denominator. So I want to combine these into one single term, which means I need a common denominator. This one's divided by 2, and this is divided by 3. It just so happens I know off the top of my head that 6, if I make them both 6, so make the first one times 3, and the second one times 2, I'll get a common denominator of 6. Now, the top part's going to be tricky here because I have two terms. I'm going to actually have to use my distributive property when I'm changing this, okay? So the left-hand side's not going to change. It's going to be 3x minus 8 over 5 is equal to. Over here, we get tricky. Now, the denominator, like we said, 2 times 3 is going to be 6. And the other one is also going to be 6, the denominator, and still going to be a plus. On top, 5 times 2 is 10. That works out nice. This part I'm going to leave because I'm going to do this in a little more detail because I know this part might be a bit tricky. So I didn't quite equate the top of this fraction here. Okay? It just so happens, and I'm going to do the next line here, the left-hand side. Whoops. That should be minus. It's going to stay the same. We haven't done anything to it. We're kind of going step by step here. Because I have a common denominator of 6 and addition, I can actually write this as a single value. I can put everything just above 6, which is nice. And the numerator is still going to stay as 3. I haven't done anything to it yet. Minus 1. And I just got to say plus 10. This is actually a little trick we can use in math to make a single fraction here. So this is helpful. I am going to first off get rid of my brackets here. And then I'm going to do that little trick to get rid of fractions. Okay? So again, left-hand side stays the same. And you might be able to do this in far less steps. I'm just trying to do it detailed. So I'm doing each of the steps as we go along. What's going to happen here is this 3 has to be multiplied by both terms in there. So 3 times 2x will actually give us 6x. And 3 times negative 1 will give us negative 3. And I still have plus 10. I can actually collect some like terms here at the end. Negative 3 and positive 10, they're going to give me a single value. So you'll notice on my left-hand side, I've collected all my like terms. I can't simplify that numerator anymore. I'm going to do the same on the right. 6x and then negative 3 plus 10 happens to be positive 7 over 6. So both of our numerators are now simplified. I can't simplify any farther. There's no more like terms. So this is where the trick comes in. I can, because this is divided by 6, I can multiply both sides of the equation by 6. Or think of it like bringing 6 to this side because of division. When I do that here, the 6 disappears. Okay, so I'm left with 6. And then my set of brackets, 3x minus 8 over 5 is equal to 6x plus 7. All right, I got rid of my fraction on the right side. In the same stroke here, I can do the same thing to this 5. I can bring that over and multiply by 5. So when we do that, without actually using distributive property, we can say, still have this 6 on the outside, 3x minus 8, that 5 cancels out on the bottom, so we don't have a fraction anymore, is equal to 5 multiplied by 6x plus 7. And just like that, we no longer have fractions. Okay? If that's a little confusing, we could have done a complete common denominator. I mean, with 5 and 6, we could have made everything over 30, changing all the numerators and working from there. But this one works really nicely. We might need a fraction in the end. But at least I'm not working with them right now. I do have to use that distributive property again. So we've done it a few times. So I'm going to try to do both sides in one step now. My 6 times 3x will give us 18x. And 6 times negative 8 will give us negative 48. And then on the right-hand side, 5 times 6x will give us 30x. 5 times 7 will give us positive 35. There we go. Now we're getting to some familiar territory. We need like terms. And in fact, we got this one and this one are like terms, and these two are like terms. So I'm going to put them on the same sides of the equation. I'm going to leave the 18x on this side, and I'm going to bring over 30. So that becomes actually negative 30x. Okay. And I'm going to leave 35 on the right-hand side, but I'm going to bring over negative 48. That actually becomes positive 48. So now I have like terms on each side. And the reason I put them on each side instead of all of them on one side is because in the end, I actually need to isolate for x. That is really the goal here. Get x by itself. So this is some of my first steps to actually get x by itself. 18 minus 30, what's that going to give me? 2, 10, 12? I think that's going to give me negative 12x. So I believe I should get negative 12x here on the left-hand side. And then 35 is going to be 83, I believe. You might want to double check me with a calculator here. 7, I think that's right. 83. So we're so close. X, we've almost got by itself. Our very last step here is to get rid of this coefficient. Well, if I divide both sides by negative 12, I end up with x is equal to negative 83 over 12. This is an improper fraction, but they happen to say in this question they want a mixed fraction. So again, I got to go through some of my fraction rules. I got to figure out how many times 12 goes into 82, and I think it is 7, to be honest. Sorry, 83. My answer is going to be negative, so x is going to be equal to some negative mixed fraction, but I'm actually going to have to take 12 and do some long division. You could do it with a calculator if you have it. I believe if I go 7 times, no, that is no, that doesn't work. 6 times. 6 times. Should give me 2, carry to 172. There we go. That gives us 11. Bring down to 0. Remainder 11. That's what's important. Remainder 11. So what that means is as a mixed fraction, this is my whole number, 6. Okay. My denominator still stays 12. And the remainder is the numerator left on the fraction. So it becomes 11. So as a mixed number, x is equal to negative 6 and 11 twelfths is a way to say this. So we zoom out a little, quite a bit to this one. This one took quite a while to get to the bottom of.